Hello, my name is Ramos, and I will be presenting the Pound-Rebka experiment. Introduction to the Pound-Rebka experiment. The Pound-Rebka experiment was done in 1959 at Harvard Jefferson's Tower by physicist Robert Pound and Glenn Rebka. They measured how gamma rays changed energy as they moved through Earth's gravity, testing Einstein's prediction that gravity could affect light. This was the first real-world proof of gravitational redshift on Earth, showing that even small gravitational forces can influence the energy of light. The experiment was a turning point because it linked theoretical physics to real measurement and helped confirm general relativity in a laboratory setting. Einstein's theory of general relativity. Einstein's theory of general relativity, introduced in 1915, changed how scientists understood gravity. Instead of thinking of gravity as just a force that pulls objects together, Einstein showed that mass bends space and time, creating that we'll feel as gravity. This theory predicted that light should lose energy when it moves upward in gravitational field. The Pound-Rebka experiment directly tested this prediction by measuring how light behaved in Earth's gravity. Their success proved that Einstein's idea wasn't just a theory, it was a physical reality. Gravitational redshift. Gravitational redshift means that when light travels upward against gravity, it loses a tiny bit of energy, stretching its wavelength and making it slightly redder. Before 1959, this was only a prediction, but the Pound-Rebka experiment gave the first real proof on Earth. Using gamma rays and Mossbauer effect, they detected an incredibly small energy change over just 22.5 meters inside Harvard Jefferson's Tower. Their work showed that gravity really does affect light, confirming Einstein's theory and demonstrating how even small gravitational forces can have measurable effects on energy. The Mossbauer effect. The Mossbauer effect was discovered in 1958, just 1 year before the Pound-Rebka experiment. It allows scientists to measure the energy of gamma rays very precisely because it eliminates energy loss caused by atomic recoil. This was essential for detecting the tiny gravitational redshift Einstein predicted. Pound and Rebka used the Mossbauer effect to measure a change in photon energy so small that it had never been seen before. Without this technology, their experiment wouldn't have been possible, showing how innovation in one area of physics can unlock a discoveries in another. The Jefferson Tower setup. The Jefferson Tower at Harvard University played a big role in the experiment. Pound and Rebka used its 22.5-meter height to measure the effect of gravity on gamma rays. They placed a gamma ray source at the top and a detector at the bottom, then measured how light energy changed as it moved up and down. This creative setup turned a simple building into one of the most important scientific tools for testing relativity. The tiny differences they detected matched Einstein's prediction almost perfectly, proving gravity changes light's frequency even across short distances. Results and confirmation. The results of the Pound-Rebka experiment matched Einstein's prediction with very small margin of error. Their data showed that gamma ray lost energy when moving upward and gained energy when moving downward, exactly as general relativity said they should. This proved that gravity affects both light and time. It was one of the most laboratory confirmations. It was one of the first laboratory confirmations of Einstein's theory, inspiring many more experiments that would test relativity with even greater accuracy. Pound and Rebka's success proved that general relativity applied not only to outer space, but right here on Earth too. Impact on astronomy. After the Pound-Rebka experiment, astronomers had strong evidence that gravitational redshift happens throughout the universe. It helped explain why light from massive stars or galaxies appears redshifted and supported ideas about black holes and neutron stars. These findings showed that the same physics measured in a Harvard tower also applies to distant cosmic objects. In other words, what Pound and Rebka confirmed on Earth gave astronomers the confidence to study how gravity affects light everywhere, from the surface of stars to the edges of black holes. Modern technology and applications. The Pound-Repka experiment results continue to shape modern technology. One of the best examples is GPS. Satellites orbiting the Earth experience slightly weaker gravity, which makes their docks tick faster. Without correcting for this difference, GPS systems would be off several miles each day. This is a direct application of general relativity, the same the same theory Pound and Repka helped prove. Their experiment also laid the groundwork for more precise instruments in physics and astronomy, showing that relativity isn't just abstract, it's something we use every day. Legacy and importance. The Pound-Repka experiment remains one of the most important achievements in modern physics. It connected Einstein's abstract ideas to measurable reality and showed that gravity affects light, time, and energy in predictable ways. This work inspired new generations of scientists to test relativity with better tools, eventually leading to discoveries about black holes, gravitational waves, and cosmic expansion. Its legacy continues in both scientific research and everyday technology. Pound and Repka proved that even a small experiment on Earth can change how we understand the entire universe. And here are my references.